Hello everyone, I welcome you all for the lecture series videos of hydraulics and pneumatics. In the previous video, we have discussed about the pressure compensated flow control valve. As we know that the flow rate can be controlled by three things. One is area of opening, second pressure difference, and the viscosity of the fluid. Viscosity of the fluid is interrelated with the temperature. Therefore, the temperature plays a crucial role for deciding the flow rate of the fluid. So, since we learned that the temperature of the any system is not constant, it keep on varying. Imagine the machine is operated at morning shift. At the first time we have started the machine, it is in the room temperature. Therefore, the viscosity of the fluid is more and it will make its own resistance to flow. So therefore, the flow rate is very less for the given pressure and the area of opening. And the system is operating for 8 hours or 10 hours, the temperature of any system or machine increases. So the increased temperature affects the viscosity of the fluid, and the viscosity reduces, then the flow rate increases. Therefore, we cannot have a control over a machine since the temperature is keep on varying. To overcome this problem, we have a temperature compensated flow control valve. So in this video, we are going to discuss about how the temperature compensated flow control valve controls the flow rate for the different temperature conditions. So let us have a deep dive on this presentation. So we know that the temperature compensation is necessary in the flow control devices for accurate and constant flow rate for any typical applications in the hydraulic system. So this is due to the viscosity change that occurs because the viscosity is the function of the temperature. So here I have illustrated the temperature compensated flow control valve. So this valve is provided with a needle. So this needle is able to slide inside the valve body. So in the valve body, we have inlet and outlet. Inlet is connected to the circuit and outlet is connected with the system or the any actuator. Maybe a rotary actuator or it may be a linear actuator. And in the needle, we have a heat sensitive metal insert. So this is nothing but in the iron box, we have a bimetallic strip which has a different coefficient of thermal expansion. So because of the different coefficient of thermal expansion, when it is subjected to a thermal load, the temperature changes, it tends to bend and it will make contact and discontact depending upon the temperature change. Here also we have a heat sensitive metal insert. Is when it is subjected to a temperature change, it tends to expand or shrink according to the temperature change. The rate of expansion or shrink of the heat sensitive metal insert is proportional with the temperature. When the temperature increases, it tends to expand. When the temperature reduces, it tends to shrink. At the top, we have a threaded stem which is preciously machined and it is able to slide inside the valve body. At the top of the stem, we have an adjusting knob. The flow rate can be adjusted mechanically. Imagine we have a mechanical adjustment. For that, the needle can be make an opening of the valve and uh, from the pressure compensated, the fluid enters inlet and it is sent to the system via this heat sensitive metal insert. When it is in room temperature, there is no change in the dimension or there is no expansion in the heat sensitive metal insert. Imagine the fluid pressure is high. So the heat sensitive metal insert senses the heat in the temperature or heat in the fluid. According to the temperature, it tends to expand. So there, when the heat sensitive metal insert is expanded, the area of opening will be reduced. So therefore, the flow rate can be adjusted according to the temperature change. If the fluid temperature is reduced and this needle come back to its original position. So this is how the temperature compensated valve makes an operation for the any hydraulic systems to control the flow rate when it is subjected to different temperature and different viscosity conditions. And these are all my references. My first reference, Fluid Power, authored by Anthony Esposito, published by Pearson Education, New Delhi in the year 2003. And my second reference, Fluid Mechanics and Hydraulic Machines, authored by R.K. Bansal, published by Lakshmi Publication, New Delhi in the year 2001. So in this video, we have discussed about the temperature compensated flow control valve, how the temperature is a function of viscosity and how the flow rate is affected, and how can we control the flow rate whenever the temperature changes. So I hope this video is useful for you. Thank you.